Hello, this is James Black. I'm showing you the Labview portion of our voltage-based temperature and first order response lab. There's a accompanying video for this about the equipment setup. It might make more sense for you to watch that first, kind of get the overview of the project. Here we're going to examine what needs to be done in our Labview programming. So here we've opened up Labview, this is kind of the home screen. If you can't find this, just go and search, and you want this one, the 2015 SP1. You don't want to pick any of these, so pick that, and if you do, this should pop up. Also, we don't want to start a project. That's more complicated. We just want a VI. So come up here to File, pick New VI. Once you do that, you should see your block diagram and your front panel. I like to give myself a lot of room and toggle between the two. You can get your own preferences. I would recommend having this tools window up here. This is our second experience with Labview, so I'll still go over a lot of the basics. If you're not seeing this, then you should come up here to View and pick your controls palette, or sorry, your tools palette. That will bring that up. One other thing beginners might want is to show context help. That can be useful. I don't show my functions palette though. I get that by right-clicking. So let's do that here. Let's right-click, and we want to start with our DAC Assistant. That's typically what we're going to be doing for this class. Go to Measurement In Out. There are a couple different ways to get to this, but one way is to go to Measurement In Out, hover over this, and then come down here to DAC Assistant. If you click that and place it here, it'll think a little bit, and then hopefully this should pop up. You know, as we talked about in the other video, we have our Labview compact DAC with a thermocouple module plugged into it, and it is connected to my laptop here via USB. So it's registering that. We want to acquire signals. We're going to use analog input. Those thermocouples are going to produce a voltage. But we don't want to just measure the voltage here. There are some built-in capabilities here to actually know what voltage the thermocouple is producing and how that translates to a particular temperature, based on the metals that are used in that thermocouple and the reference temperature. So instead we want to take advantage of those capabilities. We want to select temperature. We want to go down here to thermocouple. This will pop up and it'll ask us what channels. And I already looked at my thermocouple module, and I saw that the first 5 channels are fine to plug thermocouples into. You can actually select 5 right here. Just hold down, so pick one, the first one, and then hold down Shift and pick. So here I have 5, 0 through 4. If you wanted to skip 2 and instead get 5, just hold down Control and you can toggle these on and off. Like I said, I confirm my first 5 are good. I want to use those 5. Click Finish. It brings us to this screen. There is a lot of useful info here. We see we have our 4 channels. Let's first go to the connection diagram. We can click through here, through each of our 4 channels, and it's going to tell us which pins. So those pins are labeled on the module. It'll tell us which pin is the positive, which pin is the negative, and down here it even color codes it for us. So I have a thermocouple that is white and red. So we should have this chart here to make sure we're using the right thermocouple. That's a type J. So it's a type J thermocouple. And it's telling me the red goes to negative. That's 21. And the white is positive. That's showing the positive here. It goes to 3. That's on the positive side. That's all labeled on our thermocouple module. So make sure you go through those, get those all wired up, use the small screwdriver as discussed in the video. And once you get all that hooked up, come back here to your Express Task page. There are some important things to talk about here. Signal input range, let's talk about that first. We're using units of Celsius, so degrees Celsius, stick with the default. We are going from room temperature to anywhere between 80 and 100 degrees Celsius per the lab handout. We could bring this up a little bit. Our lab is a little hotter than typical room temperature. We could probably bring this up to 20, and maybe if you only decide to go up to 80, you could bring this down a little bit to try to reduce our range and get the best resolution possible. But this is pretty good for going from room temperature to up to 100. Like I said, I keep forgetting, but yes, thermocouple type J. You want to go through and pick this for each channel. If the default is not what your thermocouple type is, you need to go through and pick that for each one. But pick your thermocouple type, and here, so this is cold junction source. Forgetting what the second C is, but this is for our reference junction. And we are using the built-in thermocouple within our module. So we just want to stick with that default of built-in. And this defaults to one sample on demand. We don't want to do that. We want to have our VI automatically sample until we tell it not to. So we're going to pick continuous samples. That's different. The last lab, our first lab, where we used Labview, we picked the number of samples. We specified the number of samples. We don't want to do that. We don't just want one sample. We want to set up a loop of continuous samples. So let's do that. And I think the best way, so there are many ways to do all this. I think the best way for this is probably to set up our samples to read to 1 and our rate to 1 Hertz. I'll talk about why we're choosing those more, but for now, let's just set those and let's pick OK once we have that set up for all of our channels. So you can look here and confirm that's set up for all of our channels. OK. Now it'll spend some time building our VI, and when it's done, it'll look a little different than what it did before. So first we get this window here. It wants us to confirm that we want auto loop creation. It says you have configured this task with a mode that typically requires you to place the DAC Assistant Express VI in a loop. Would you like to automatically create the loop now? Yes, we do want it to do that. And this is what that looks like. You have the automatic tool selection selected here. You can come over and pick this and expand it out. We're going to need to add some more things in here, and we can move this a little bit more up here to give us a little more room. You'll see we have this stop button. So a little about this stop button. This is a stop within our loop. So when we select this, let's go over here to the front panel. We see we have our stop button. When we select this, it stops, it goes through that last loop we're in, and then it stops the program. It does it in a controlled way. So once we hit stop, once we create our VI, we hit start up here. We have this other stop button up here, and this is kind of a more hard stop. To use the words of Professor Larson, this is when your hair is stuck in the lathe and you want to hit the emergency stop or cut the power. This just hard stops everything. If you don't have if it hasn't been writing, so if you don't have your write to spreadsheet within the loop, all that data will be lost. It just cuts you off. But here's a little bit more of a controlled stop. This is more what we're going to want to use in our case. So let's expand this down, and we're going to want to give us a little bit of capability I'll tell you why in a little while, to have control of both our number of samples and our rate. So you come to the little arrow, you right click on it, come to create, and you hit control. So you get rate and number of samples, and those show up on our front panel. They're both set to 1 like we set when we were using our DAC Assistant. Now, let's do this next. From the front panel, right click, go over here to graph. Last time we actually created a waveform graph. This time we want to pick the waveform chart. The reason for that is, so we're in this loop, and the waveform graph would plot the data that we collected in that loop. And then when it comes through the loop, it would refresh with the updated data collected in that new loop. And we wouldn't see like the history of the data that we've been collecting. The waveform chart will keep all that data from each previous run through the loop. And that will be more useful in our case, especially since we only picked 1 sample. There are some advantages to this, but for now, just note we're picking a waveform chart. This is going to allow us to see our data as it builds up over time. Now that we put that in here, we should go over to our block diagram and we see that waveform chart. Now we want to wire our data to this waveform chart so we can test to see that our program is working. So once we've done that, I believe we should be able to run a little test here. Let's go back to this and let's just run it once. There we see, oh, so the 5th one's down there at the bottom. Okay, I was thinking we only saw 4, but we see all 5 of our thermocouple outputs. We see 4 of them at 27 degrees roughly, and we see the 5th one at 23. That 5th one is going to be our thermocouple that is just kind of hanging out by itself. I have a little thermometer right here checking the room temperature, and it's actually 24.4 degrees Celsius in our lab. It's pretty warm. And the thermocouple is pretty close to that. The 4 that are embedded in there, they're likely a little bit hotter because that aluminum rod was in the bath not too long ago. Actually, it's been a while. It's cooled down quite a bit, but that's why they're cooling down more slowly. They have all that thermal mass in the aluminum rod. They're at a higher temperature right now. If I reach over here and I'm going to grab that one little thermocouple that's hanging out, and we see it jumping up. So it should jump up to something like 36 Celsius. I believe that's body temperature in Celsius. It's going up to 32. Well, clearly it's responding. I just let go of it. So we're seeing that I'm getting data that makes sense. It's dropping back down to room temperature. I touch it again, it's going back up. This is a pretty good test to make sure that we're getting good data. Let's stop this. So we stopped it, finished up that loop. Now let's right click here and let's see. Trying to remember how to show our chart, have it show all the data we've collected. Probably here, X scale. There. So now we can see all the data we've collected. We see those 2 times that I grabbed it and let go. So it seems like my thermocouples are connected to the module's in the compact DAC chassis, we got the USB to my laptop, the VI is set up so that it's exporting data as we would like it to, data that makes sense, into the laptop, or into my waveform chart. Now we just need to set it up so that it will actually save our data to something that we can use, most likely an Excel spreadsheet. So let's go back to the block diagram. Let's right click to bring up our functions palette. Let's go to the file in out and let's do write delimited spreadsheet. Click that, bring it over here, and let's go back to the automatic tool selection. Let's get our spool. Let's bring it over here to 1D data. Now we should be recreating our time axis based on our sampling rate. Since that's just 1 hertz, every data we collect is going to be 1 second, so that's fairly easy to recreate. But here we're bringing in 1 data. We're just going to have, it should be giving us, just with this initial setting, a data point for each of our thermocouples in a row. So 5 points in a row. That's fine. We want then for it to, next time it goes through the loop, to not just add those same, or not to add the new data points over our old data points, but just to keep appending it to the file. So let's go to this, hover over this until you find the append to file one, or you can maybe see it over here in your context help more quickly. Once you're there, right click, create, control, and there's our append to file. Now, so this is going to be a little more complicated than last time. We're going to need to set some kind of a delimiter for our data to be easily imported into Excel. Actually, let's leave that out for now. I'll show you why. Let's just run this and see what our data looks like. We should go back over to our block diagram. Sorry, not the block diagram, the front panel. And we should turn on our append to file. So see, the automatic tool selection works pretty well a lot of the time. Sometimes it gives us some trouble. But let's pick this. So if the automatic tool selection isn't working for you, pick the little hand, come over and press your append. Now we're just kind of giving it a try here. Oh wait, I'm sorry, there's one more thing we gotta do before we give it a try. We do need to come back over here and find the file path. That should be this one. Right click, create, control. We can't skip this part. Let's put that up here. Now if we go back to our front panel, you should see this file path. You can move things around however you want them. Let's save this so we don't lose our work. So we're in a file of lab 3. Let's just call this thermocouple, so TC for thermocouple lab VI. Now, to specify the file path, this takes us to that same location. I like to just click up here, hit Control C to copy. Instead of hitting OK, hit cancel. Come here and paste that in. You can do your slash and put your file name in. So data1, and I like to use CSV files. I think if you set this up right, it's easier to import into Excel. So we got that set up. Now I think we're ready to give it a shot. If we want, we can, let's see here, data operations, clear chart. If we want to just start with a clean slate, we can do that. We can hit run. We see those. I'll reach over again. See that little thermocouple that's dangling out, go up and down. So we have some data to look for, and that's good. Let's stop it. Now if we go to our file, we should see that data that we just saved. If we double click on this, it takes us right to Excel. And if you look here, all of our 5 data points are merged into one. I believe we have our 5 thermocouples here in a row, but they're just not separating into separate columns. That's what I suspected was going to happen. I wanted to show you that. Now we'll go back to that delimiter that I mentioned. If we hover over delimiter, right click, create control, go back to our front panel, and it puts in the symbol for a tab. So switch to the text tool, just put in a comma. So it's comma separated value. That's what that CSV file is. So we're telling that it actually separates the values with a comma. So Labview will create the CSV file in the format it should normally be created in. If we do that, and let's now save our data as data2, and let's run it. There we see it. It's adding on to what we already plotted on the chart. And if I grab it, it jumps up. I let go of it, drops down. My file should only be from roughly right here where we started this new set of data and include this. So let's stop it and see if now our file looks like it should. So now data 2, open it up, and there it is in columns. Now one of these will be that thermocouple that's just dangling down. You won't know which one is which just from looking at it and wiring it up. But once you collect data, you'll be able to see which ones are the ones that are embedded further and further up into the rod. And it looks like here we jumped up in our temperatures. So most likely, suspecting C might be our channel that's just dangling out. Let's test that. Just create a chart with it. There, that looks like the channel that jumped up and then slowly cooled down when I let go of it. Here. So you're going to want, I suspect that if we just plot all this data, it's not going to look quite right. I think it will interpret the first axis. Yeah, it interprets the first axis as our x values. We don't want that. So let's come in here, insert, and you can create your time axis. Like I said before, it's just 1 second for each data point because of our sampling rate. We can create that. Oops. We can plot it. We see all of our channels looking as they should. So it looks like everything's working. One note I mentioned to you that I would tell you a little more about this rate. And we kind of have to split the difference here. We have one thermocouple that's hanging out there, and it's going to have a really fast response. You see when I grab it, it just jumps up high in temperature, and when I let go of it, it drops down quickly. That won't be the same case for the ones that are embedded in the aluminum rod. You'll see that each one that's embedded further in will take significantly longer to heat up. And you might be running this for something like 30 minutes until you get to a value that you can consider equilibrium, possibly even more. For that reason, we don't want to have a really high sampling rate because we don't want to have Googles and Googles of data points. But then at the other end, we only want to, for that quick one, the one that's dangling out, we want to get enough points to actually capture it. 1 Hertz works fairly well. It gives us a good number of data points for those 4 that are embedded in the rod. It might be kind of difficult to get a good response measured to get enough data points for that one that's hanging out. If you go through all of this and you get good data, at least for those 4, and you get decent data for that one that's hanging out, you may possibly want to go back. Just because that one so quickly cools back down, you may want to come back after you're done, set a higher sampling rate, and just capture that one thermocouple, not worry about the other thermocouples in the rod having been cooled down to room temperature or not. Just as a little example, I'll show you some data from a previous run through of this. I hope. There we go. So here, actually, we're not seeing the quick one jump up. But we're seeing here over a fairly long period of time that it takes these thermocouples to rise to a level that's close to equilibrium. And you should note that, so the one that was just hanging out there got close to the 90 degrees that we have the bath set at. These other ones, you could sit there for a long time and they're not going to get close. As they're further up that rod, you have heat's conducting through that rod, radiating out to the air around. Those are likely never going to reach the 90 degrees that you have it set at. You should run it long enough until you get to a fair approximation of an equilibrium value, and you would determine that from here. Just don't expect to get to 90. And sorry, I don't have an image of that one little, actually I could show you that. Let's stick this thing in the bath. Let's go back here. Let's dead operations, clear chart. Let's get this running. So we'll put this in at 3. Data 3. Let's start it running. I'm going to go over and put that specimen into the bath. You see how that jumps up? There are only maybe like 5 or 6 data points there to capture that whole response. For that reason, you might want, and because we don't want to collect too much data for the others, you may want to come back, because that one cools down easily or quickly, and just capture that one by itself at a higher sampling rate. But the other ones, the other 4 should work fine at this sampling rate. You can see we're getting lots of data points as they slowly make their way up to 90. Well, that should be more than enough for you guys to complete your lab. Good luck with it. I'll see you later.